Hey everyone, it's Robotics Coordinator Jake here, and today I'm going to show you a little bit about LEGO robotics. I'm here in the LEGO room at the Boys and Girls Club in Leominster, and we're going to talk a bit about some of the projects that you can do with these LEGO robotics kits. This is only a small fraction of what we do here in the LEGO room. We also do LEGO design, as well as competition robotics, which I'll talk about a little bit later. So what I have here is a robot that was designed by members and staff here at the club. Members did a lot of the work, heavy lifting on this piece, but this kind of drives like a car. So as you see, I move the buttons. I'm in control mode for the EV3 brick. This is the main control center of the whole robot, and I'm in motor control mode. So I am controlling everything from the brick, as you can see. And then let's set the wheels to that direction and then start driving. You notice it turns kind of like a car in a very wide arc. So come over to the LEGO Mindstorm's EV3 software. This software is available for free on LEGO's website. You can mess around with it, but unfortunately running any program does require a brick to run, but you can find some tutorials online for how to use this software, and it's going to be a handy bit of knowledge to have because some of these concepts like loops and stuff transfer over. So I want to get this to drive. So let's bring the large motor block A, that's the A motor, port in the motor in the A port, which is the large motor driving the back wheels. And we're going to run it at 75% power for 1 revolution. Let's see what happens. Well, that didn't go as expected. It went backwards. So how can we fix that? Well, we have 2 options with this brick, or this block. We can either change the power from 75 to negative 75, telling it to go the opposite direction, or we can tell it negative rotations. I think negative power sounds better because it goes the opposite direction, so we'll do that. We'll go to negative 75. Now let's see what happens. Good, we've got it going forward now. So now let's add another wrinkle. Well, we want to get the steering right. The steering uses a medium motor, which is a long, thin one. That's in port D. And let's not go for a full rotation. Let's go for a half rotation, which actually has to be expressed as 0.5, decimal equivalent of 1/2 of 1. Let's undo the drive brick because we know what that does. Let's see what happens with the turn brick. Well, it seems to be going the opposite direction of the turn we want because it's all the way to the left. Let's change that again to negative 75 and see what happens. There we go. Great. Now we've managed a turn using the software, completely autonomously using the software. That's great. Now let's combine those things together. We'll turn and then drive. So get it to turn all the way. It had to go 0.5 revolutions. Let's change that to 0.25, half of 0.5. And we'll go back the opposite direction because now we want to go to the right, or go to the left. Let's see what happens. That worked out great. It went straight, or turned to go straight, and then went straight. That's pretty good. What happens if we do that again then? Well, that's not what we wanted. We wanted it to continue going straight. It kept turning to the left. So that's a problem we're going to have to overcome. We may have to manually set it up to drive straight and then start our program. So let's do this. What happens if we have these things happen at the same time? Well, how can we do that? Well, let's separate these blocks off the start block, and now we can connect them here. So now each block is connected to the start button, but branching off immediately off the same path. They used to go one after the other. Now let's see what happens when they happen side by side. What happens again? Let's run it again. It seems like the turning motor is a little more responsive than the big motor, but they're definitely happening right about the same time. It's not waiting for the turning motor to do its thing and then running the big motor like it was. So that's cool. Let's see what happens if we chain a bunch of the turning actions together. To do that, we add another medium motor block. We're going to tell it to run 0.25, 0.25, the opposite direction of this one. So in theory, that should zigzag. Let's also make this run a little longer, so that way we can see the results. So that definitely turned twice while it was moving. Can we chain this again? So let's copy and paste the two motors here and chain them in. See what happens this time. I think we can get that zigzag motion more defined if we reduce the time or increase the time between the turns. So let's go into the flow control section, the orange section, and bring in this hourglass piece. This is called a wait. So this is going to wait 1 second between actions. We're going to leave this one without a wait in between so we can see the quick turn. Let's increase the length of this again, so that way we get a good chance to take a look at what's going on. Great, we got a good motion out of that, and it turned twice, and then reset to go straight for a while, and then turned again. That's exactly what we were looking for. And this is just the surface of what you can do with the LEGO Mindstorms EV3. This software and hardware gives you infinite possibilities, from building a crane that you can automatically pick stuff up, to a simple little whirligig gizmo. And that's the great thing about LEGO. There's always something new to do, always something you haven't tried, and there's always something new to find out and explore. So I want to thank you for watching today. This is another one in our robotics series. Also do LEGO Design and First LEGO League. This is a competition where we use these EV3 bricks to complete challenges that are set forth on a competition table. This is a great program. I recommend you check it out. Go to firstinspires.org/FLL if you want to learn more. Again, thank you very much. For stuff to talk about, show us what you've done with Legos if you have any at home or are interested in doing. Like, do you want to build robots? Do you want to build structures? Do you want to build both? Let us know in the comments. Thanks again. Robotics Coordinator Jake here. Have a great day.